Hey, altruistic followers and well-wishers, I presume you are here and here are in a fine fettle in 2021 too, in spite of the second corona wave in India with high mortality rates. It's social activist and good-hearted preacher Pradesh Suresh back with sheer ecstasy for my 135th video on angle of publication on YouTube today, 17th May 2021, Monday. The topic for today is perils of usage of plastics and allied materials. Plastic is a good invention, but usage without thinking of the consequences has only led to adverse impacts on humans, animals, and other marine species, besides environmental degradation. One should be very careful when it comes to applications, and there should be foolproof plans for safe disposal. Plastics are a wide range of synthetic or semi synthetic materials that use polymers as a main ingredient. Their plasticity makes it possible for plastics to be molded, extruded, or pressed into solid objects of various shapes. This adaptability, plus a wide range of other properties such as being lightweight, durable, flexible, and inexpensive to produce, has led to its widespread use. Plastics typically are made through human industrial systems. Most modern plastics are derived from fossil fuel based chemicals like natural gas or petroleum. However, recent industrial methods use variants made from renewable materials such as corn or cotton derivatives. In developed economies, about a third of plastic is used in packaging and roughly the same in buildings in applications such as piping, plumbing, or vinyl siding. Other uses include automobiles. Up to 20% plastic is used in automobiles, furniture, and toys. In the developing world, the applications of plastics may differ. 42% of India's consumption is used in packaging of plastics. In the medical field, polymer implants and other medical devices are derived at least partially from plastics. Worldwide, about 50 kg of plastic is produced annually per person, with the production doubling every 10 years. The world's first fully synthetic plastic was bakelite, invented in New York in 1907 by Leo Baekeland, who coined the term plastics. Dozens of different types of plastics are produced today, such as polyethylene, which is widely used in product packaging, in polyvinyl chloride, PVC used in construction and pipes because of its strength and durability. Many chemists have contributed to the material science of plastics, including Nobel laureate Hermann Schrödinger, who has been called father of polymer chemistry, and Hermann Mark, known as father of polymer physics. The success and dominance of plastics starting in the early 20th century has caused widespread environmental problems due to the slow decomposition rates in natural ecosystems. Towards the end of the 20th century, the plastics industry promoted recycling in order to assuage environmental concerns while continuing to produce virgin plastic. The main companies producing plastics doubted the economic viability of recycling at the time, and this is reflected in contemporary plastic collection. Plastic collection and recycling is largely ineffective because of the complexity of cleaning and sorting post-consumer plastics. Most plastics produced has not been reused, either being captured in landfills or persisting in the environment as plastic pollution. Plastic pollution can be found in all the world's major water bodies, for example, creating garbage patches in all the world's oceans and contaminating terrestrial ecosystems. The word plastic derives from the Greek plastikos, meaning capable of being shaped or molded, and in turn from plastos, meaning molded. As a noun, the word was most commonly used to refer to the solid products of petrochemical derived manufacturing. The noun plasticity refers specifically here to the deformability of the materials used in the manufacture of plastics. Plasticity allows molding, extrusion, or compression into a variety of shapes, films, fibers, plates, tubes, bottles, and boxes, among many others. Plasticity also has a technical definition in material science referring to the non-reversible change in form of solid substances. Most plastics contain organic polymers. The vast majority of these polymers are formed from chains of carbon atoms without the attachment of oxygen, nitrogen, or sulfur atoms. These chains comprise many repeating units formed from monomers. Each polymer chain consists of several thousand repeating units. The backbone is a part of a chain that is on the main path, linking together a large number of repeat units. To customize the properties of a plastic, different molecular groups called side chains hang from this backbone. They are usually hang from the monomers because the monomers themselves are linked together to form the polymer chain. The structure of these side chains influences the properties of the polymer. Plastics are usually classified by the chemical structure of the polymer's backbone and side chains. Important groups classified this way include the acrylics, polyesters, silicones, polyurethanes, and halogenated plastics. Plastics can be classified by the chemical process used in the synthesis, such as condensation, polyaddition, and cross-linking. They can also be cross-linking. They can also be classified by the physical properties including hardness, density, tensile strength, thermal resistance, and gas transition temperature. Plastics can additionally be classified by the resistance and reactions to various substances and processes, such as exposure to organic solvents, oxidation, and ionizing radiation. Other classification of plastics are based on qualities relevant to manufacturing or product design for a particular purpose. Examples include thermoplastics, thermosets, conductive polymers, biodegradable plastics, engineering plastics, and elastomers. Thermoplastics do not undergo chemical change in their composition in heater and thus can be molded repeatedly. Examples include polyethylene, PE, polypropylene, PE, PP, polystyrene, PS, and polyvinyl chloride, PVC. Thermosets or thermosetting polymers can melt and take shape only once. After they have solidified, they stay solid. If reheated, thermosets decompose rather than melt. In the thermosetting process, an irreversible chemical reaction occurs. The vulcanization of rubber is an example of this process. Before heating in the presence of sulfur, natural rubber, polyisoprene, is a sticky, slightly runny material. After vulcanization, the product is dry and rigid. Biodegradable plastics are plastics that break down upon exposure to sunlight or ultraviolet radiation, UV, water, or dampness. Bacteria, enzymes, or wild abrasion. Attacked by insects such as waxworms and mealworms can also be considered as forms of biodegradation. Aerobic degradation requires that the plastic be exposed at the surface, whereas anaerobic degradation would be effective in landfill or composting systems. Some companies produce biodegradable additives to enhance biodegradation. Although starch powder can be added as a filler to allow some plastics to degrade more easily, such treatment does not lead to complete breakdown. Some researchers have genetically engineered bacteria to synthesize completely biodegradable plastics such as polyhydroxybutyrate, PHP. However, these are relatively costly at present. While most plastics are produced from petrochemicals, bioplastics are made substantially from renewable plant materials like cellulose and starch. Due both to the finite limits of fossil fuel reserves and to rising levels of greenhouse gases caused primarily by the burning of those fuels, the development of bioplastics is a growing field. Global production capacity for bio-based plastics is estimated at 327,000 tons per year. In contrast, global production of polyethylene and polypropylene, PE and PP, the world's leading petrochemical derived polyolefins, and was estimated at over 150 million tons in 2015. Common plastics include both commodity standard plastics and engineering plastics. Polyamides, PA, are nylons. Fibers, toothbrush bristles, tubing, fishing line, and low-strength machine parts such as engine parts or gun frames. Polycarbonate, PC, compact discs, eyeglasses, riot shields, security windows, traffic lights and lenses. Polyester, PES, fibers and textiles. Polyethylene, PE, a wide range of Inexpensive uses including supermarket bags and plastic bottles. High density polyethylene HDPE detergent bottles, milk jugs, and molded plastic cases. Low density polyethylene LDPE outdoor furniture, siding, floor tiles, shower curtains, and clamshell packaging. Polyethylene terephthalate PET carbonated drink bottles, peanut butter jars, plastic film, and microwave packaging. Polypropylene PP bottle caps, drinking straws, yogurt containers, appliances, car fenders and bumpers, and plastic pressure pipe systems. Polystyrene PS, foam, peanuts, food containers, plastic tableware, disposable cups, plates, cutlery, compact disc, and cassette boxes. High impact polystyrene, HIPS, refrigerator liners, food packaging and vending cups, polyurethanes, PU, cushioning foams, thermal insulation foam, surface coatings, and printing rollers. Currently, the sixth or seventh most widely used plastic, and for instance, the most commonly used plastic in automobiles. Polyvinyl chloride, PVC, plumbing pipes, guttering, electrical wire, cable insulation, shower curtains, window frames, and flooring. Polyvinyl chloride, PVDC, food packaging such as saran, acrylonitrile, butadiene styrene, ABS. Electronic equipment cases, example computer monitors, printers, keyboards, and drainage pipe. Polycarbonate plus acrylonitrile, butadiene styrene, PC plus ABS, a blend of PC and ABS that creates a stronger plastic used in car interiors and exterior parts and mobile phone bodies. Polyethylene plus acrylonitrile, butadiene styrene, PE plus ABS, a slippery blend of PE and ABS used in low-duty dry bearings. Basically, plastics are used in all walks of life, including spacecraft, attributed to economics and ease of molding. There are specialized plastics like furan, resin-based on furfuryl alcohol used in foundry sands and biologically derived composites. Melamine, melamide, used at high temperature composite materials. Melamine formaldehyde, MF, one of the aminoplasts used as a multi-colorable alternative to phenolics, for instance, in moldings. Example, break-resistant alternatives to ceramic cups, plates, and bowls for children, and the decorated top surface layer of the paper laminates. Example, Formica. Phenolics are phenyl formaldehyde, PF. High modulus, relatively heat-resistant polymer with excellent fire resistance, used for insulating parts in electrical fixtures, paper laminated products. Example, Formica and thermal insulation foams. It's a thermosetting plastic with a familiar trade name Bakelite, which can be molded by heat and pressure when mixed with a filler like wood flour, cast in its unfilled liquid form, or cast as foam, oasis. Plastarch, biodegradable and heat-resistant thermoplastic composed of modified cornstarch, polydiketoenamine, PDK, a new type of plastic that can be dipped in acid and reshaped endlessly, currently being lab tested. Epoxy, used as an adhesive, a faulting agent for electrical components, and a matrix for composite materials with hardness including amide and boron trifluoride, and polyether ketone, PEEK, strong chemical and heat resistant thermoplastic. Its biocompatibility allows for use in medical implant applications and aerospace moldings. It is one of the most expensive commercial polymers. Polyether imide, PEI, in materials such as Kapton tape, polylactic acid, PLA, are a biodegradable thermoplastic converted into a variety of aliphatic polyesters derived from lactic acid, which in turn can be made by fermenting various agricultural products such as cornstarch, once made from dairy products. Polymethyl meth- methacrylate (PMMA) acrylate contact lenses of the original hard variety glazing, best known in this form by its various trade names around the world. Example: perspex, plexiglass, and oroglass. Fluorescent light diffusers and rear light covers for vehicles. It also forms a basis of artistic and commercial acrylic paints and is suspended in water and the use of other agents. Polysulfone, high temperature melt processable resin used in membranes, filtration media, water heater, dip tubes, and other high temperature applications. Polytetrafluoroethylene, PTFE, or Teflon, heat resistant, low friction coatings used in non-stick surfaces of frying pans, plumber's tape, and water slides. Silicones, polysilicones, polysiloxanes, heat resistant resins used mainly as sealants, but are also used for high temperature cooking utensils and as a base resin for industrial paints. Urea Formaldehyde (UF), one of the aminoplasts used as a multi-colorable alternative to phenolics, used as a wood adhesive uh, for plywood, chipboard, hardboard, and electrical switch housings. Oxo biodegradation is biodegradation as defined by the European Committee for Standardization (CEN) in CEN PR 1535-2006 as degradation resulting from oxidative and cell mediated phenomena either simultaneously or successively. This degradation is sometimes referred oxo-degradable, but this later term describes only the first or oxidative phase of degradation and should not be used for material which degrades by the process of oxo-biodegradation as defined by CEN. The correct term is oxo-biodegradable. In 2019, by the EU Directive 2019-904, Article 5 of the European Parliament and of the Council, 5th June 2019, the introduction of single-use plastics made from oxo-degradable plastics was prohibited. There are two different types of biodegradable plastic: vegetable-based plastics which are loosely known as bioplastics, uh, compostable plastics, are tested in accordance with ASTM D6400 or EN 13432 as to the ability to biodegrade under conditions found in industrial composting or biogas facilities. Also, biodegradable plastics are made from polymers such as polyethylene, polypropylene, or polystyrene, contain a pro-degradant catalyst, often a salt of manganese or iron, and are tested in accordance with ASTM, American Society of Testing Materials D6954 or BS 8472 or AFNA Accord T51808 as to the ability to degrade and then biodegrade in the open environment. In pro-degradant catalyzes the abiotic degradation process so that oxo-biodegradable plastic will degrade. The presence of oxygen much more quickly than ordinary plastic. The plastic material has been converted into small chain organic chemicals such as ketones, alcohols, carboxylic acids, and low molecular mass hydrocarbon waxes. The remaining chemicals are no longer plastic and are biodegradable by bacteria which are ubiquitous in the terrestrial and marine environments. The timescale for complete biodegradation at any time or place in the open environment is much shorter than for conventional plastics, which in normal environments are very slow to biodegrade and cause large scale harm. Degradation is initially prevented by the presence of polymer stabilizers in the plastic, which ensure a useful service life for the article. Once the stabilizers have been exhausted, oxo biodegradation will begin. The chemical mechanism is that of oxo degradation. Auto oxidation, but it is greatly accelerated by the presence of metal catalysts, which promote the homolysis of hydroperoxides into free radicals, which drive the degradation process. Access to oxygen is essential, and oxo-degradable plastics will not degrade if buried deep in landfill. Conventional polyethylene and polypropylene plastics will typically fragment quite quickly, but then will take decades to become biodegradable. Oxo-degradable plastic, if discarded in the environment, will degrade to oxygenated low molecular weight chains, typically molecular weight 5 to 10,000 AMU, atomic molecule. Okay, within 12 to 18 months, depending on the material, resin, thickness, antioxidants, etc., temperature, and other factors in the environment. Biodegradation is up to 91% has been observed in a soil environment within 24 months when tested in accordance with ISO 17556. Oxo degradation has been studied at the Eurofins laboratory in Spain, where on 25th July 2017, they noted 88.9% biodegradation in 121 days. The statement about biodegradation of oxo-degradable plastics have, however, been disputed by the EU, European Union. In a 2017 report, it was stated that the biodegradation of the fragmented pieces is only partially supported. Oxo-degradable plastic, including plastic carrier bags, may degrade quicker in the open environment than conventional plastic. However, according to a report from the European Commission, there is no evidence that oxo-degradable plastic will subsequently fully biodegrade in a reasonable time in the open environment, on landfills, or in the marine environment. According to a 2018 report, sufficiently quick biodegradation is in particular not demonstrated for landfills and the marine environment. A wide range of scientists, international and government institutions, testing laboratories, trade associations of plastic manufacturers, recyclers, and other experts have therefore come to the conclusion that oxo-degradable plastics are not a solution to the environment, and that oxo-degradable plastics is more suited for long-term use, recycling, or composting. There is considerable risk that fragmented plastics will not fully biodegrade, and a substantial risk of an accelerated and accumulated amount of micro and nanoplastics in the environment, especially the marine environment. The issue of micro and nanoplastics is long acknowledged as a global problem in need of urgent action, not just in terms of cleanup of littering, but also of plastic pollution prevention. One major problem with the testing by oxo-degradable plastics for safety is that current standards and test methods can't realistically predict the biodegradability of plastic carrier bags within natural ecosystems. Moreover, existing biodegradability standards and test methods for aquatic environments do not involve toxicity testing on account for the potentially adverse ecological impacts of carrier bags, plastic additives. Polymer degradation products are small, microscopic plastic particles that can arise via fragmentation. A 2019 EU report describes oxo-degradable plastics as oxo-degradable plastic means plastic materials that include additives which through oxidation lead to fragmentation of the plastic material into microfragments or to chemical decomposition. Plastic pollution is the accumulation of plastic objects and particles, example plastic bottles, bags, and microbeads, the Earth's environment that adversely affects wildlife habitat, and humans. Plastics that act as pollutants were categorized as into micro, meso, or macro debris based on size. Plastics are inexpensive and durable, making them very adaptable for different uses. As a result, humans produce a lot of plastic. However, the chemical structure of most plastics renders them resistant to many natural processes of degradation, and as a result, they are slow to degrade. Together, these two factors allow large volumes of plastic to enter the environment as mismanaged waste and for it to persist in the ecosystem. Plastic pollution can affect land, waterways, and oceans. It is estimated that 1.1 to 8.8 million tons of plastic waste enters the ocean from coastal communities each year. It is estimated that there is a stock of 86 million tons of plastic marine debris in the world. The worldwide ocean, as of the end of 2013, with an assumption that 1.4% of global plastics produced from 1950 to 2013 has entered the ocean and accumulated there. Some researchers suggest that by 2050, there could be more plastic than fish in the oceans by weight. Living organisms, particularly marine animals, can be harmed either by mechanical effects such as enlargement in plastic objects, problems related to ingestion of plastic waste, or through exposure to chemicals within plastics that interfere with the physiology. Degraded plastic waste can directly affect humans through both direct consumption, that is in tap water, indirect consumption by eating animals, and disruption of various hormonal mechanisms. As of 2018, about 380 million tons of plastics is produced worldwide each year. From the 1950s up to 2018, an estimated 6.3 billion tons of plastics has been produced worldwide, of which an estimated 9% has been recycled and another 12% has been incinerated. This large amount of plastic waste enters the environment. Studies suggesting that the bodies of 90% of seabirds contain plastic debris. In some areas where there have been significant efforts to reduce the prominence of free-range plastic pollution, though reducing plastic consumption, litter cleanup, and promoting plastic recycling. As of 2020, the global mass of produced plastic exceeds the biomass of all land and marine animals combined. A May 2019 amendment to the Basel Convention regulates the exportation, importation of plastic waste, largely intended to prevent the shipping of plastic waste from developed countries to less developed countries. Nearly all countries have joined this agreement, but the world's largest producer of plastic waste, the United States, opposed it. The trade in plastic waste has been identified as a main culprit of marine litter. Countries importing the waste plastics often lack the capacity to process all the material. As a result, the United Nations has imposed a ban on waste plastic trade unless it meets certain criteria. There are three major forms of plastic that contribute to plastic pollution: microplastics as well as mega and macroplastics. Mega and microplastics have accumulated the highest densities in the northern hemisphere, concentrated around urban centers and waterfronts. Plastic can be found off the coast of some islands because of currents carrying the debris. Both mega and macroplastics are found in packaging, footwear, and other domestic items that have been washed off ships and discarded in landfills. Fishing-related items are more likely to be found around remote islands. These may also be referred as micro, meso, and macro debris. Plastic debris is categorized as either primary or secondary. Primary plastics are in their original form when collected. Examples of these would be bottle caps, cigarette butts, and microbeads. Secondary plastics, on the other hand, account for smaller plastics that have resulted from the degradation of primary plastics. Although modern life would be hard to imagine without these versatile chemistry products produced composed of plastics also have a dark side, due in part due to the very characteristics that make them so desirable, their durability and longevity. Ralph Halden, associate professor in the School of Sustainable Engineering at Arizona State University, US, and assistant director of environmental biotechnology at the Biodesign Institute, did a survey of existing scientific literature consisting of the hazards of plastics to human health and to the ecosystems. Will depend on his findings. We depend on his findings, which appear in one of the latest issues of the Annual Review of Public Health, was sobering. Today, plastics accumulate in garbage dumps in landfills and are sullying the world's oceans in ever greater quantity. And plastics and their additives aren't just around us, they are inside virtually every one of us, present in our blood and urine in measurable amounts, ingested with the food we eat, the water we drink, and from other sources. Halden's study reiterates the fact that the effects to the environment from plastic waste are acute. Measurements from the most contaminated regions of the world's oceans show that the mass of plastics exceeds that of plankton 6 foot. Patches of oceanic garbage some as large as the state of Texas hold a high volume of non-biodegradable plastics. Aquatic birds and fish are increasingly victims of because the biodegradation processes are inadequate to eliminate this durable reuse. The magnitude of society's burden of plastic waste is only the beginning to be fully appreciated. In the US, the average person produces a half pound of plastic waste every day. Around the world, some 300 million tons of the material are produced each year, a figure poised to expand as new forms of plastics are devised to serve a voracious global appetite. Voracious. As Halden points out, this annual production alone would fill a series of train cars encircling the globe. We are doomed to live with yesterday's plastic pollution. We are exacerbating the situation with each day of unchanged behavior, he said. Adverse effects to human health remain a topic of fierce controversy. Though a growing consensus is emerging that plastics and their additives are not always the benign companions we once assumed them to be. Halden says he accepted the invitation to write about plastics and human health because the topic showcases the bigger problem of how to create a sustainable future for modern civilization. Two broad classes of plastic-related chemicals are of critical concern for human health: bisphenol A, BPA, and additives used in synthesis of plastic, which are known as phthalates. Halden explains that plastics are polymers, long chains of molecules usually made of carbon, hydrogen, oxygen, and silicon, which are chemically linked together or polymerized. Different polymer chains can be used to create forms of plastic with unique and useful properties. BPA is a basic building block of polycarbonate plastics such as those used for bottled water, food packaging, and other items. While it has been considered benign in the form of a heavily cross-linked polymer, its bonds can break down over time when plastics are repeatedly washed, exposed to heat or other stresses, liberating the building blocks of the chemical, which are toxic. BPA has been recognized since the 1940s as an endocrine disrupting chemical, EDC. That interferes with the normal hormonal function. Adding to the health risks associated with the BPA is the fact that other ingredients such as plasticizers are commonly added to plastics. Many of these potentially toxic components also can leach out over time. Among the most common is a chemical known as diethyl hexyl phthalate or DEHP in some products. Notable medical devices, including intravenous bags or tubing, additives like DEHP can make up to 40 to 50% of the product. If you are in a hospital hooked up to an IV drip, Halden explains the chemical that oozes out goes directly into your bloodstream with no opportunity for detoxification in the gut. This can lead to unhealthy exposure levels, particularly in susceptible populations such as newborns. What are the overall effects of the phthalates plastics in we unwittingly ingest? The literature Halden surveyed is ambiguous on this point, despite more than half a century of study. Part of the difficulty lies in the absence of good controls for studying health outcomes, as plastic exposure is a global phenomenon, and finding unexposed subjects for comparison is nearly impossible. Controlled. It is known, however, that health effects vary depending on who is exposed and when. Infants and pregnant or nursing mothers are at a heightened risk for toxic exposure or passage of BPA and additives like DEHP. This January, the FDA announced, Drug Authority announced an important reversal of its 2008 claims regarding the safety of BPA, expressing new concern about potential effects of BPA on the brain, behavior, and prostate gland of fetuses, infants, and children, and pledging to collaborate with other federal health agencies to re-evaluate the chemical safety. Studying the effects of low-dose exposure is tricky, usually requiring a very large number of study subjects. Instead, epidemiologists tracking the problem frequently base their conclusions on data gathered from individuals known to have unusually high levels of the chemical, often the result of high-level occupational exposure. Halden insists that further study on low-dose exposure is essential to settle the matter of health risks, noting some evidence in the literature suggests that high-dose studies may be inadequate to properly understand toxic brazen misuse has led to a radically unsustainable condition. Today, there is a complete mismatch between the useful lifespan of the products we consume and their persistence in the environment. Prominent examples of offending products are the ubiquitous throw-away water bottles, Teflon-coated dental floss, and cotton swabs made with the plastics PVC sticks. All are typically used for a matter of seconds or minutes, yet are essentially non-biodegradable and will persist in the environment sometimes for millennia. Despite the scourge of discarded plastics and the health risks these substances pose, Halden is optimistic that society can begin to make wiser choices and develop more sustainable products formed from biodegradable and non-toxic chemical building blocks. New forms of polymer, some made from renewable materials that are digestible by microorganisms, are being explored. Ultimately, converting to petroleum-free construction materials for use in smart and sustainable plastics will become a necessity, driven not only by health and environmental concerns, but by the world's steadily declining oil supply. As Halden emphasizes, the manufacture of plastics currently accounts for about 8% of the world's petroleum use. This is a lot of petroleum. Oxygen, a seizable chunk which ultimately contributes to another global concern, the accumulation of carbon dioxide in the atmosphere. Ozone depletion. We are at a critical juncture, Halden warns, and cannot contribute under the models that has been established. If we are smart, we look for replacement materials so that we don't have this mismatch. Good for a minute and contaminating for 10,000 years. Harmful effects of plastic bags on health and environment. Using plastic bags in packaging of hot bread and meals makes these bags flexible and able to interact with the high heat, resulting in release of the carcinogenic dioxin. The lightweight and high consumption of plastic bags the ability to persist for long periods of time in the environment without decomposing made them one of the main factors of pollution in the open spaces, public squares, the main roads, inside and outside cities, sea, beaches, and water. Easy evaporation and wide use of plastic bags also destroy the general appearance of the places where they are. When plastic bags stick to trees and plants, they obstruct the natural light from reaching parts of the plant, causing impairment in the process of photosynthesis. Plastic bags cause diseases and even death to the cattle that come across and eat them during pasture. Not only cattle, even elephants die. Burying of plastic bags in soil makes an insulating layer that keeps rainwater in the upper part of the soil and prevents water and other fertilizers from reaching its lower part. Yeah, there was a sandalwood smuggler in Tamil Nadu, India, whose name is Veerappan. There is a saying that he killed like 3,000 elephants over a period of 30 years. He never used to shoot the animals or hunt them. He used to feed them food mixed with the plastics. Those elephants used to swallow all that and they'll die within days because they cannot digest the plastic that they had eaten. They'll pick up infection and die. And then this guy will go there and cut off its tusk and all that and sell it in the market. Okay, that's a long story. Plastic bags create a fertile environment for the growth of infectious bacteria. Accumulation of plastic bags in water blocks the irrigation canals and drainage networks. Burning of plastic bags causes the emission of chlorine, dioxide, carbon dioxide, dioxin, other gaseous components, acids, and many harmful toxic components. Carcinogens, basically, cancer causing. Plastic bags pose danger to the environment and marine organisms when they exist and pile up in the coastal areas. Using plastic containers to save food, especially pickles, acid, and fatty food, causes plastic to decompose and toxic carcinogens to access the body. Leaching, it will leach, like leaking. Tips to curb wide use of plastic. Use paper or cloth bags instead of plastic bags. Reuse plastic bags for many times to reduce consumption and hence curbing the production of them. Use glass containers such as Pyrex. Use of plastic bags can be reduced through codification by imposing heavy taxes or fees on the production of them. Compliance with the proper criteria and standards on the production of plastic bags makes the bags thicker, more durable, and biodegradable. Reduce the use of plastic wrapped products. Mothers should be cautious not to use plastic bottles for feeding their babies. Do not buy plastic toys which children can chew. Not only children, even dogs and others. Chew and replace them with the toys made of natural materials. Do not buy or use plastic cups, plates, or spoons, especially the disposable single-use ones. For parties and all, that's what they use. Even hotels are using them widely. If you select between different plastic products, choose a product that can be reused or recycled. Yeah, even for food in South India, they used to serve food on plantain leaf. Nowadays, instead of plantain leaf, they are using like plastic leaf. Same color, almost the same color, green, olive green. Do not take more plastic bags than you need when shopping. In case you buy a product in a plastic can or bottle, reuse it for other purposes instead of disposal. Avoid using plastic cups made of rigid polystyrene in drinking tea, coffee, and other hot drinks. Use paper or glass cups instead of bisphenol. A controversy centers bisphenol A, BPA. Controversy centers on concerns and debates about the biomedical significance of BPA, bisphenol A, which is a precursor to polymers that are used in some consumer products, including some food containers. The concerns began with the hypothesis that BPA is an endocrine disruptor, that is, it mimics endocrine hormones and thus has the unintended and possibly far-reaching effects on people in physical contact with the chemical. Since 2008, several governments have investigated its safety, which prompted some retailers to withdraw polycarbonate products. The US Food and Drug Administration, FDA, ended its authorization of the use of BPA in baby bottles and infant formula packaging based on market abandonment, not safety. The European Union and Canada banned BPA use in baby bottles. The US FDA, Food and Drug Administration, states BPA is safe at the current levels occurring in foods, based on extensive research, including 2 more studies based on the issued by the agency in early 2014. The European Food Safety Authority, EFSA, reviewed new scientific information on BPA in 2008, 2009, 2010, 11, and 15. EFSA's experts concluded on each occasion that they could not identify any new evidence which would lead them to revise their opinion that the known level of exposure to BPA is safe. However, the EFSA does recognize some uncertainties and will continue to investigate them. In February 2016, France announced that it intends to propose BPA as a REACH regulation candidate substance of very high concern, SVHC. The European Chemicals Agency agreed to the proposal in June 2017. According to the European Food Safety Authority, BPA poses no health risk to consumers of any age group, including unborn children, infants, and adolescents at current exposure levels. But in 2017, the European Chemicals Agency concluded that BPA should be listed as a substance of very high concern due to its properties as an endocrine disruptor. In 2012, the United States Food and Drug Administration (FDA) banned the use of BPA in baby bottles intended for children under 12 months. The Natural Resources Defense Council called the move inadequate, saying the FDA needed to ban BPA from all food packaging. The FDA maintains that the agency continues to support the safety of BPA for use in products that hold food. The U.S. Environmental Protection Agency (EPA) also holds the position that BPA is not a health concern. In 2011, Andrew Badge, the chief scientist of the United Kingdom's Food Standards Agency, commented on a 2011 US study on dietary exposure of adult humans to BPA, saying this corroborates other independent studies and adds to the study on dietary exposure of adult humans to BPA, saying that this corroborates other independent studies and adds to the evidence that BPA is rapidly absorbed, detoxified, and eliminated from humans. Therefore, it is not a health concern. The Endocrine Society said in 2015 that the results of ongoing laboratory research gave grounds for concern about the potential hazards of endocrine disrupting chemicals (EDC) consisting, including BPA, in the environment, and that on the basis of the precautionary principle, these substances should continue to be assessed and tightly regulated. A 2016 review of the literature said that potential harms caused by BPA were a topic of scientific debate, and that further investigation was a priority because of the association between BPA exposure and adverse human health effects, including reproductive and developmental effects and metabolic diseases. BPA leads to obesity, thyroid disorders, infertility. As of 2018, current evidence shows a possible positive correlation between BPA, lowest sperm quality, decreased motility, and an increase in sperm immaturity. There is tentative evidence to support the idea that BPA exposure has negative effects on human fertility. For behavioral outcomes, BPA mimics estrogenic activity and affects various dopaminergic processes to enhance mesolimbic dopamine activity, resulting in hyperactivity, attention deficits, and a heightened sensitivity to drugs of abuses. Cancer, since it's carcinogenic, endocrine disruptor, higher BPA exposure has been associated with increased self-reporting of decreased male sexual function. Studies in mice have found a link between BPA exposure and asthma. A 2010 study of mice has concluded that prenatal exposure to perinatal exposure is 10 micrograms per milliliter of BPA in drinking water enhances allergic sensitization and bronchial inflammation and responsiveness in an animal model of asthma. Despite a rapid soil and water half-life of 4.5 days and an air half-life of less than 1 day, BPA's ubiquity makes it an important pollutant. BPA has a low rate of evaporation from water and soil, which presents issues despite its biodegradability and low concern for bioaccumulation. BPA has low volatility in the atmosphere and lower vapor pressure between 5.00 and 5.32 pascals. BPA has high water solubility of about 120 milligrams per liter, and most of its gastric reactions in the environment are aqueous. Interesting fact is that BPA dust is flammable if ignited. It has a minimal explosive concentration. Also in aqueous solutions, BPA has shown absorption of wavelengths greater than 250 nanometers. The ubiquitous nature of BPA makes a component an important pollutant to study, as it has been shown to interfere with the nitrogen fixation The roots of leguminous plants associated with the bacteria Symbion, Cynorhizobium meliloti. A study published in JAMA Pediatrics has found that prenatal exposure to BPA is also linked to lower lung capacity in some young children. BPA affects growth, reproduction, and development in aquatic organisms. Among freshwater organisms, fish appear to be the most sensitive species. BPA is known as an endocrine disrupting compound, EDC, and has major neurological effects on vertebrates. All of us are vertebrates. BPA is an environmental contaminant that disrupts the ecology. The most profound effects observed in vertebrates. BPA infiltrates the environment by running off of landfill. So, because of this, it is mostly found in water. Aquatic vertebrates are the most affected by this form of pollution. BPA has major effects on the behavior of vertebrates, especially in the sensory processing systems. Plastics affects human health, uses plenty of petroleum products for production, reducing the availability for other productive purposes, contaminates drinking water, leads to increase in air pollution, affects our food chain, increases land pollution, affects wildlife, water pollution, which affects marine species adversely. So it is quite clear that plastics are very harmful to humans, animals, and aquatic species and degrades the environment. We should wake up at least now and put a stop once and for all to usage of plastics in our day-to-day lives. Come up with better alternatives to plastics, which may increase the cost of living, but it is worth every penny since our expenditure on upkeep of our health will reduce in the long run. Take a holistic view rather than a saddle horse, also known as narrow perspective. It is certainly possible if all of us work as a team and fight against the corporates who have designed systems that are profitable to one and only them. They have zero concern for the society and environment. Psychopaths, basically. We lived without plastics for so long, for so many centuries, and let us adapt ourselves to such life and learn to live in harmony with nature. I wish Greta Thunberg is here with me. She is an environmental activist. Debates, discussion, and open-ended topics like this can go on forever. Anyhow, let me put the plug here. We'll meet again real soon with another interesting topic. Some of the statements, views expressed are solely mine based on limited knowledge gained over 6 decades of versatile experience. Always watch these videos with a closed caption. Subtitles for absolute 100% comprehension has been a sincere recommendation zillion times so far. I know I rushed through to complete the presentation within 20 minutes maximum. This time limit is self-imposed to retain the viewer's attention as a norm. I am quite aware of the fact that I exceed this time limit. Sometimes I take double or even triple this time, depending on the topic, since I make honest attempts to cover the selected topic more elaborately, including so many intricate fine details referring a wide variety of sources, in particular Wikipedia quite extensively, besides articles and books published recently. Besides, of course, I sprinkle my own salt and pepper and season it with my personal experiences so far in my life and also intuition. Stay at home as much as possible to maintain social distancing. attributed to the pandemic novel COVID-19 and prolong your lifespan. Lead a healthy life. God alone, God, also known as the supreme power, is the one and only one who can put a stop to natural and unnatural events, maybe bio-war and cyber-war events like pandemics and epidemics, which ultimately pays for apocalypse and extinction of all sentient species on Earth for no fault of the others. Rest in peace and harmony. Today I have taken 56 minutes.